Hello everyone. In this video, we will see some loop related programming problems, right? So we will see some basic problems and then some intermediate problems and some important problems, okay? So we will start soon. So we will not, bother about all the programs, but we will just, revise more and more with the difficult problems, okay? We will revise difficult problems more, okay? So if you just type everything, then you may waste time, right? So we will start from the beginning. In our first program, we have a program of printing numbers, okay? So we will provide a number, and we will print all the numbers up to that number, okay? Like if we provide 10, so we will print 1 from 10, right? So what we will do, we'll just explain this, and maybe we won't, maybe we won't type everything, but we will try to understand, okay? And whatever program we find it difficult, we will try to explain it properly, and uh, we will try to practice some more time, okay? So let's see what happens. Okay, so here you see the program. We have an integer variable, and we are saying to the user that enter n, that means enter a number, right? And this scanf function will take the input, okay? And now we will print in the screen that numbers from 1 to that number, whatever number the user provides, right? If user provides 10, so 10 will be here. And this for loop will start from 1, okay? And this will iterate up to n or less than n, okay? So as I starts from 1, so uh, you know array index and the element is will be equal, right? So if array starts from 0, then maybe in the place of n, in the position n, uh, index would be one number less. I hope you understand, right? So that means if I goes up to n, okay, so if it's less than n or equal to n, we are covering one from that number, right? So we can't say here just less than n. You understand? If we say less than n, then it will be 1. If we provide 10, it will print 9, okay? If you see here, enter n. This is the problem we face with array, guys, for loop, guys. Sometimes we don't understand what actually is happening, right? Where we start from, 0 or 1. If we start from 1 and if we start from 0, these things make us confused. When I started, or every beginner uh, face this problem. So let's say we provide 10, so you see numbers from 1 to 10, okay? So okay, so you see here, you need to notice this, that after d there's a space, right? If you don't provide space, and all the numbers will be you know so close, okay? You see here, so we need to provide this space, right? Then we will have a space in the output as well. You see here, okay? So let's do one thing. If we provide here 0, and what happens, okay? If we provide here 1, no, not 0, 1, and these, if we don't provide equal, then it will provide you see 9. It will provide up to 9, okay? It doesn't provide, this is because what? This is because n, if n is less than I, and I start from 1, we will get only 9 elements, okay? uh, if you want to get 10 elements, if you provide from I from 0, let's see what happens. Okay, so we get 10 elements, but it starts from 0, right? So 0 was 0, 0, 1, 2, 3, 4, 5, 6. So there is 9 digit here, and the 0, 1, 0 here, okay? So we get 10 elements, but it starts from 0, and it's printing the 0 2, okay? So that is why we get 10 elements, but not we are not getting the 10 number. So if you want to get 10 number, you have to start from 1 and you have to equal less than or equal to n, then you will get so these things you need to be careful, guys, and you need to just play with these things, guys. This is how you learn. Okay. uh, okay, so let's move on to our next program. Next program is uh, print numbers in reverse from n to 1. Okay, so we will the slide change will be here. Okay, so it will just not plus plus I not plus plus, I will be minus minus, and things will be fine here. You see, integer n, everything is fine here. It up to now, up to this line, everything is same line. If you see this program, you see here, this is all already in the, like the previous one, right? So here, numbers, this line is also always there, and everything is like before, but here you see I starts from n, because it we will start from the 10, right? So we will start from not from 1, we will start from the upper number, from the limit, right? So we are starting from n, and as far as I is greater than 1 or equal to 1, right? Because we will decrease one by one. So when I will be more than 1, I in the beginning I is 10, and then I'll be 9. So as far as I is more than 1 or equal to 1, I will minus minus, right? If you see here, if we provide 10, you see 10 9 8. So I hope you understand the logic. Yeah, so if these logics make you confused, guys, uh, pause the video, write the whole code. Okay, and uh, and if you think these things are easy for you, so revise always. Okay, revise, and if you need this code, please make a comment. I'll give you the code, right, if you need it. And sum of numbers. Okay, so if you see sum of numbers, sum of first n natural numbers. Okay, so uh, so when you make when we calculate sum, uh, usually in the maximum case, in the beginning sum starts from 0, right? Some variable holds a value 0, right? You see here, and we are saying that enter n, give us number, and the user will give a number. And you see here, I will in the for loop I will start from 1, and I will up to that number, n, okay, less than or equal to n, and I plus plus, and sum equals to sum plus I, that means 0 plus I. So in the first iteration, 0 plus 1, it will be 1, 0 plus, in the second iteration, 0 plus 2. Okay, so this is how it will iterate up to I, as far as I is less than or equal to n. Okay, so this is how it will work, guys, and every time sum will be uh, adding the numbers, right? And when the loop terminates, sum of first natural numbers, then n will be printed and sum will be printed, right? If you see here, if you provide 10, you see here 55, right? Sum of first 10 natural numbers. Okay, so we know that a natural number starts from 1. Okay, so if we include 0, this will be whole number. Okay, so some students ask me, what's the difference between natural and whole? Why two different kind of different kinds of names here? Why whole number, natural number? Natural numbers are also whole number. I mean, uh, you can say not fractional number. These are integer, right? So naturals are also integers, and whole numbers you can say also integers. So why two different names? If you ask someone that how many children you have, so there might be no children in his family, right? So in this case, you have to include 0. So 0, when you include 0, then it's a whole number, right? And when you just exclude 0, then it becomes natural number. Anyway, guys, I hope you understand the logic. And if you feel less confident, then see the program and try to uh, write this code on your own. Okay, yeah, I will, maybe in another video I will try to practice with you guys. If you just watch my video, then you'll be fine. Okay, you don't need to uh, uh, feel less confident. Just do with me, and uh, when you watch my video, talk to me. Feel like you're talking to me. Yeah, so when I make video, guys, I feel like I'm talking with you. This is how I can I can entertain myself. uh, I can stick with the process, right? Anyway, uh, then we will move to our next program. Sum of even or odd numbers up to n, right? So in this program, this will be easy too. This will not be that hard, guys. You see here, we have okay, so forget about these variables first. Okay, so just think about the number. We will say the user, give us a number, right? Give me a number, then enter n. So we will take the for taking the number, we need a variable, right? We need an address. We need to put the number input in an address. So we are giving address of n, right? So we can declare n. Okay, so for integer I starts from 1 and I is less than or equal to n, and we will go to up to that number. Okay, and it will start from 1, not from 0. And if I modulus 2, if I modulus 2 equals 0, then we will sum even. Okay, so sum even is variable and it starts from 0. So 0 plus I. Okay, so if it's if it's evenly divided. Okay, so if it's not evenly divided, then this condition will be false. So when this condition is false, it will go to the else condition, right? So here we will do the sum odd. Okay, so for sum odd, if this condition fails, then this condition would be definitely true, right? And when everything will be done in the for loop, then it will come in the print statements, right? So some of the even numbers, then it will print the even numbers, and some of the odd numbers, it will print the odd numbers. Okay, so this is how things will work, guys. Enter n. If we give 10, so sum of even numbers, right? So here it will start from 1 and it will one step by step. Okay, so do you think you need to visualize this? If you want to visualize, uh, you can let me know in the comment, right? Okay, so okay, so let me visualize, guys. I will show you how it works. And okay, so just take the problem's name. Okay, problem's name, and we will try to just visualize the for loop, guys. Okay, for loop. If you in case you don't understand, right? So first iteration I starts from first iteration I starts from 1, and 1 less than or equal to 10, right? So it's true, then it's true, so loop will enter into here, right? If I, that means 1 modulus 2 equals 0, right? So when we divide 1 by 2, right, so we will get uh, modulus 0, right? Okay, so here if I means 1, right? 0. Okay guys, so when if I, that means 1 modulus 2, right? So 1 modulus 2 is not 0. Okay, so we will get the result 0, but remainder would be 1. Okay, because 2 can't divide 1, so the whole 1 would be remainder, right? So this would be false, and false, right? So else would be, else would be implemented, sum equal to sum plus I, right? So sum to sum plus I, sum odd should be here, sum odd. So sum odd was 0 plus 1, it would be 1, right? And for 2, and for the second iteration, for the second iteration, I would be 2, and 2 is less than 10, and 2 modulus 2 is 0. It would be true, right? It would be true, and this thing will sum even, right? Even, and this would be 0, and this would be 2, right? Because I is 2, right? So this is how it will work, guys. And for the this is the second iteration, and for the third iteration, for 3, you see here, for the third iteration, I will be 3, and 3 is less than 10, and 3 modulus 2, it will not be 0, it will be 1, right? So this will be false, and here our uh, our this will be in action, right? So else would be here sum odd. So it is, sum odd is 1 here, because previously sum odd was 1, right? So 1 plus 3 here. Sum odd, in the first iteration we got the odd number, and 1 was there already. Okay, so 1 was stored in sum odd, right? So that 1 would be here, that 1 would be in here, and 1 plus 3, it would be 3, right? I hope you understand. And for the fourth iteration, this is how it will work, guys. Fourth iteration, it will be 4, right? So for the fourth iteration, if we take fourth iteration, I will start from 4, and 4 is less than 10, and 4 modulus 2, so it should be true, right? So sum even, previously sum even was 2, so 2, and here it will be 4, right? Sum even was 2, and this would be 4, so it would be 6, guys. Okay, so if you take 5 now, in our fifth iteration, it will be 5, right? So 5 would be added with 3, right? Because in case of 5, this would be false again, and for 6 it would be true again. So when we iterate for 6, so 6 would be added with 6, right? And for 7, so 7 would be added with uh, for 7, uh, if statement would be false, so it will come into else again. So this is how it works, guys. For odd numbers, this add with odds, and for even numbers, this add with even, right? So this is how this work, guys. Okay, so I hope you understand, and just practice these things. Okay, if the logic confuse you, so you just need to practice again and again, right? So we will do this tomorrow as well, maybe some other day, but we need to keep practicing these things, guys. Okay. So dogs are barking outside, guys. It's okay. Factorial of a number, right? So okay, we will see 7 or 8 problems today. All of the all would be basics, right? So factorial of a number. So I hope you understand what factorial is. So what if you don't understand, I'm just telling you what factorial is. If you give me a number like 4, okay, so if I multiply 1 and 1 into 2, okay, and into 3 into 4, so 1 into 2 is 2, right, and 2 into 3 is 6, and 6 into 4 is 24. This is what factorial is, okay. So whatever number you provide, if you provide maybe 10, so all the previous numbers will be multiplied by each other, and including 10 as well. So whatever number you get is the factorial of 10, okay. So if you see here, so uh, integer n, and here we see unsigned long, right. You see here, we will see that to enter a number, so user will give us a number, and we will have a for loop, right. So for loop starts from 1 and I is less than or equal to n, and factorial equals to factorial into I, okay. So whatever factorial is, in the beginning is 1, okay. So in the first iteration, 1 into 1, it would count 1 into 1, right, and for the second iteration it would count 2 into 1, and the third iteration 2 into 1 is 2, right. In third iteration it should be 3 into 2. So this is how it will iterate, guys, okay. So why we are taking unsigned long here, okay. So if you see here, if I show you the screen, why unsigned long? Factorial growth. Factorial of a number n is the product of all integers from 1 to n, okay. So for example, 5 is 120, 10 is this, and 20 is this, a very large number. So when you're taking a very large number, when if you take 50, then it will be a huge number, right. So size of data types, okay. So if you take integer types of data, it just typically it's 4 bytes, right. So that means 32 bits, okay. So range is, so this range can be stored in integer types of variable, right. So this is the range, guys, and this is a huge number, right. So this is why unsigned long is typically 8 bytes. 8 bytes means 64 bits. So this can store in a more than comparatively large number. So this is the limit, 0 to this, right. But as when you say integer can store minus number as well. But when you say unsigned long, it starts from 0 and up to this number. So when you count factorial, we don't count minus numbers, right. We don't consider minus negative numbers, right. So this is why we can take unsigned long. Why unsigned? Factorials are always non-negative because they are a product of positive integers. Using unsigned extend the positive range, doubles it compared to signed types, okay. So now I hope, guys, you will understand the output of factorial, right. So if you provide here like 10, I'm sorry, guys, 10, you will see this one, right. So our next problem is multiplication table, right. So what is multiplication table? We already know that 2 into 1 2, 2 into 2 4, 2 into 3 6. So this is what multiplication table, guys. So we're providing a number n, and we're saying the user to enter a number, right. So this is the variable, and we're taking input from the user, right. So multiplication table of that number, whatever the number is. And now, in multiplication table, we know we multiply a number up to 10, right? So if you take from 1, and this I will be up to 10, right? So less than or equal to 10, then I plus plus, right? So now we will have to provide in the number first. So if you want to multiply 4, if you want to get the multiplication table of 4, then 4 should be first, and then I, guys, right? And then I means 1 2 3, because I will iterate, right? I will change. The first iteration I'll 1, second iteration I'll 2, I'll be 2. This is how it will increase. And n into I, that means 4 into I. So this is how you'll get the result, guys. If you see here, enter a number like 4, you see, multiplication table, and for this backward slash n, we're getting the new line, right? And for this 3% d sign, we're getting 3 values, right? This n is for 1, this I is for 1, and this this percentage d, okay, this percentage d are for these variables. Okay, guys, one thing we need to notice about the factorial program. Okay, so when you declare unsigned long factorial, we also uh, for factorial of this n was integer, right? So this is why we provided percentage d, but this is LLU. Okay, you see, because the factorial will be the factorial's type is unsigned long. This is why LLU. Okay, so we need to focus on these things too, guys. Otherwise, we will be in trouble, right? Okay, so our next program is counting digits. Okay, I'm sorry, guys. You see here, uh, so there is a number here, number variable, and count also a variable. This is also integer, and it starts from 0, right? And enter an integer, we're saying to the user, and we're taking the input. Okay, so in while loop, number less than 0, while number not equal to 0, when number is not equal to 0, we will increase the count, right? So count 0 would be 1, and now number will be divided by 10, and that number will be stored in this variable too, right? If you want to visualize this, let's say we want to take, let's say 123, right? Let's just say take a number. We want to visualize this, and for this we just uh, let's say we're taking the counting digits. Just take this. Okay, okay, so sorry, guys. For loop, first iteration, font has been changed, guys. Anyway, no problem. It's convenient for us because it's little bit bigger, right? Okay, so when you take, while, there's no for loop, it's while loop, guys. I'm sorry. While loop, first iteration, we're taking, uh, we're taking while n not equal to 0, right? to this 1 2 3 not equal 0, right? Let's say put this in a way, okay. So here count would be plus plus, so count would be count plus 1, okay. So count equal to count plus 1. So in the beginning count is 0 plus 1 would be 1, right? And now n equals to n divided by 10. So if we divide 1 to 3 divided by 10, so you know what we will get, okay. Okay guys, so when you divide 1 to 3, I mean 123 by 10, we get 12, okay. So it gets, it goes 12 times. So 10 multiplied by 12 equals 120, right? It's an integer, guys. We it's a division, it's not the remainder, right? So we will get 12, okay. So this the extra 3 will not be considered in our case, because it's this is not we are not getting the remainder here, we are getting the the result of the division, right? So here we will get a 3 and our count is 1. That means so whatever the count we get, it will be the total number of digits in our program, right? So see, for the so to, for the second iteration it will be 12, right? So 12 not equal 0. First iteration would be, previously it was 1, and okay, so previous count was 1. 1 plus 1 equals to, it would be 2, and here we will get the result 10. 12 divided by 10, we will get 1, right? So 1 will be the result here. And this is our second iteration, guys, right? This is our second iteration, and while is not equal to 0, right? 1 is not equal to 0, and you will get third iteration here. Third iteration, count equal to count plus 1, and here it will be 2, right? Because previous count was 2 in here, right? And 2 plus 1, it will be 3. So n, now n will be divided, n is 1, and 1 divided by 10, right? So you will get 0, result 0, right? So 0 is not, when it will try to iterate again, 0 is not equal to 0, it's not true, because 0 is 0, okay. So 0 is equal to 0, so this is how it will be false, and the while loop will terminate, guys. So we are getting count 3, right? So this count will be printed, right? Number of digits, count is being printed as a number of digits, and we get, if we get 1 2 3 here, if we so we get 3. So I hope you understand, guys. Okay, so let's move to our next program, guys, and this is a reverse a number, right? So if we see the program, you see we're saying that enter a number, okay. So this will take the input, and we have a while loop, so everything happens in the while loop, guys. And we have a reversed variable, which is initially it's having a 0, right? So we now have to visualize these, guys. And if we just take the name of the program, reverse a number, right? So just take the name, and we will try to visualize these, guys. Okay, we'll just while. Let's say in this case we will think about the 1 to 3 as well, right? 1 to 3 not equal to 0 in our first iteration, right? First iteration, digit equals to number modulus 10, right? So let's do it. Digit equals number modulus 10. So what this mean? Number means 1 to 3 modulus 10 means 3, right? Because if we multiply 12 by 10, we get 100 20. So 3 will be rest, right? 3 will be remainder. And what's the next line? Reversed. Okay, so reversed means in this variable we will put reversed into 10. So whatever is reversed now, 0 into 10, this means 0 and plus digit, so digit is 3, right? So if you take this line, so reversed, that means reversed is 0 into 10 would be 0 plus 3 would be 3, guys. Okay, and what's the next line? Next line is number divided by 10, right? So number is 123, right? So number equals to number divided by 10. So number is 1 to 3 divided by 10 equals to 12. Okay, so we are getting number 12. And now, is our number 0? No, our number is 12, right? So now we will get our second iteration, guys. Here, while 1 to 3 is not, is 12, second iteration, right? Second iteration digit equals to number, that means 12 divided by modulus 10. So here in our case, let's say now, and we'll get 2, right? So reversed into reversed into 10 digit. Okay, so reversed 0 into 3. Okay, so previously reversed was 3, right? So here we will get 3, guys. 3 into 10 plus 3. Okay, so 30 plus 3, 33, right? I'm sorry, guys. Here this is our uh, digit, right? So digit was 2, so you will get 32, guys. Okay, so 32, and finally our for the third iteration digit is number. So what the number is here? Number is 1 modulus 10, right? So here modulus 10 would be 1, guys, because 10 doesn't go in 1, so 1 would be the rest, right? Reversed. So what was the reversed, guys? Reversed was 32, right? So 32 into 10 plus digit was 1, right? So 32 into 10, 32 plus 1, 32 into 10 into 320 plus 1 equals to 321. And the number is 1 divided by 10 equal to give us 0, guys, right? So when we get 0, our for loop will terminate, guys, and finally we get the reversed number 3 to 1, and our number was 1 to 3, right? So this is how we get the reversed number, guys. So these were the program, guys. Thank you for watching this video. Here we discussed all the basic programs of for loop, right? So thank you for watching. We will explore some intermediate and advanced problems in the next video, and we will revise them too. Okay, so that we don't forget. Thank you for watching.